So, what I want to talk to you about today, really, and to quote Monty Python, now for something completely different. We're not a smart cities, intelligent environment group. We focus more on the robotics side and engaging with complex environments that are inside four walls, smaller scale, safety critical. Time is important. And I broke this talk up into two different areas because at this university there are two principal areas of interest, which are online simulations, so engaging with these systems physically in front of you, and there are offline simulations. What do we do in the lab when we have a sample of something and we need to analyze it? So, and I'll talk a little bit about what our group is and where we want to go in the future. So, at its face, the Twinality Project is a toolbox that we've developed that brings together a couple of different technologies that help us transport and containerize robotic environments and move them between the lab and bring them into the shop floor. So as you can imagine, there are multiple different problems that are associated with this, and for those of you who aren't familiar with the robotic environments, I'll be a little bit more verbose and try and help out here. But there's a huge amount of information that needs to move from the lab and to the shop floor and back again. And this involves investing in different tech stacks, involving compatibility of different robots, communicating things as abstract as safety decisions, and as well as low-level code that tells the robots what to do. But then there's also things like training on the human side of this conversation. How do we communicate what is an application? There's loads of information trapped inside this environment. So over the last three to 4 years, we've been developing this pipeline to use as a transmission mechanism or a knowledge exchange mechanism to basically maximize the movement of this information from universities, where the conversation is more academic, to shop floor, where the conversation is more goal-orientated and more centered around functionality values, things that are that the company itself is focused on. So thank you very much, Rob, for mentioning this, because one thing I'll add as well is over the last 2 years, I've spent as much time as I physically can going out to these companies and trying to have that conversation that you were talking about, Rob, because sometimes this is just about communication. It's like the understanding of this process is very different on two sides of this problem, and yet the knowledge has been lost in that transmission. So the pipeline that we've developed is essentially a modular digital twinning framework. What this allows us to do is to containerize complex, multi-elemented physical and digital twin combinations. What this essentially allows us to do is engage with different APIs, different robotics platforms, things like augmented reality, virtual reality, different mechanisms for interacting with this data, but also things like, well, having conversations about financial components in the same conversation about data I/O, which is, it allows us to tackle a range of different issues just by combining different services and different entities to build the right application. So I thought it would be more interesting to show rather than tell. I know we've seen a lot of graphs already, so I hope you'll appreciate this. So online. So one thing I didn't mention is that we at the University of Sheffield, we engage with these different platforms, different applications in different ways. And this work predominantly occurs either in the nuclear AMRC, the AMRC, the University of Sheffield, University of York, as well as Sheffield Hallam. Basically, everyone who's talking about digital twins at this university, we want to be involved with. So if you are working in this space, preferably around robotics, please do come and talk to me. We also work with the HSE to engage in conversations about how we can talk about robotic applications, robotic processes in a way that supports regulators, in a way that helps them attack this complicated and sophisticated environment when their conversation may typically involve engaging with paper. Thank you, Casey. The example was resonated very well of that room with the paper. Because again, we're dealing in some cases with SMEs, especially in Sheffield, and the ones I've spoken to, is a pen and paper industry. So what we want to do is move them into a space where we can help them engage with technologies like this. So other projects we've been involved with are in the nuclear sector, and one of the things we will try and take advantage of here is standardizing our approach to applications, standardizing our use cases, our discussion about robotics, about sensors, and about how we move that information from the offline world to the online world and back again. so that we can make things more repeatable. We can talk about models offline and online in mixed environments, and we can move away from the data extraction and the databasing, I/O, and more into the area of decision, focused around achieving value in the projects that we're working with. Do I point here? Do I point here? Is that what's happening? Okay. Okay. So here's a couple of little snapshots. I've been engaged in many projects on this theme, so I'm just trying to show you something a bit more visual rather than talk about this instead. So one of the interesting things that we can see here is we can take this data the digital twins capture, and once we've abstracted away the hardware, we can start having conversations that are much more in the moment, using that data to push the boundaries on things like safety, to push the boundaries on things about how we know where the physical world is or is not aligning with the digital world, and can we use technology to help us automatically keep track of the differences. And my favorite video at the top here, this is an example of us taking a click-and-place application and using nothing but data, make a contact-based interaction, and make it non-contact, just using data. So what typically happened there, the robot would punch you in the face. Don't worry, it's only with 5 newtons, it's okay. But with data, it doesn't happen at all. It's a much more sociable system. So there's examples of us moving into the physical world, using digital twins to enhance the application, to enhance our understanding of the systems that are involved. What happens when we move the system away from it? Say we don't have access to the hardware. Say we need to we want to expose that situation to the same critiques, to the same interactions, but this time we focus more on the analysis of those scenarios. So the approach we've developed for this, sorry, I'm really dry mouth. The approach we developed for this is quite sophisticated, but it feeds on the idea of turning the system, this framework, into a digital twin builder. And working with companies like Boeing, in the top left-hand corner, one of their CNC manufacturing processes at the AMRC. We can containerize this, turn this into a digital twin that we can run offline or online, depending on the availability of hardware. And when we put the system, this application, through this process that we see on the right-hand side. And this helps us expose such a complicated, multi-layered application into something that is digestible and can be interacted with in different ways, online, offline, depending on the application. Boop. So you want to play? Okay, cool. So here's what that digital twin looks like. We've taken this environment that we had a conversation with Boeing about, and we're interested in creating a digital twin of. And what the question at hand here was, how can we improve a collaborative robotic application that involves a human model, human behavior, modeling behaviors of humans, but also with an understanding of what the robot is and how it behaves. We proposed a series of standardized models that represent the humans, represent the robots in this conversation, but then taking the entire system offline as a simulation so that we can test drive different safety control mechanisms, what happens when the system falls apart, and when does it fall apart, more importantly, with the view that everything that happens inside this world, it's very convenient, 3D, very attractive, everything inside this world represents a gateway to the potential data from the real world system. So those systems can be easily transferable, as I mentioned before. Oop, I will get this. So right now, the techniques and what we've learned from this, we've basically looked at containerizing more of these applications. How do we have a conversation about a wider range of systems? How do we standardize things like the discussion around robotics and safety? How do we help people and companies engage with complex environments where the understanding of the individual system is left to experts? So how can we have a conversation with the expert of the system and the expert of the safety side? Because often these are different individual people who may not communicate. And the way we found to do this is to start with the standards. move forward with the standards and help the companies have conversations at multiple levels by capturing that data inside these applications, revising the application, not the tools that they use to build the application. So all of this is moving towards a single piece of software that we're looking to put together between the nuclear MRC, the AMRC, and the groups that we work with here at the university, including my colleagues, John and Arian. We're trying to basically create a single pipeline that helps people, especially those at the university who work on this type of software, take environments, make it portable, make it analyzable using standardized approaches, make it possible for us to move it into the shop floor more quickly, give us a constant way of being assured that if we analyze the system in the lab, it reflects what would happen on the shop floor. And this software is something we're hoping to release this year. So, again, my name is James Douthwaite, and again, thank you very much for bringing me in today. I'll be look forward to meeting you all after this conversation. And if you want to come and talk to me about anything in robotic, please do, or not. But yeah, very keen to know more about digital twins and how you're using them. Thank you.